Okay, so here we have a problem where we have to differentiate this thing here. It's a quotient, which means that it's one function divided by another. First things first, I'm just going to label this y, so that when I'm differentiating or finding dy by dx. Second thing to note is that the numerator and the denominator are both composite functions. In other words, they are made up from a function of a function. So in the top line, it's the cube of 2x minus 3, and on the bottom line, it's the exponential of 3x plus 2. So we're going to have to use the composite rule there. But I'll do a few shortcuts so that makes that a little bit, it makes the solution a little bit shorter. First of all, the quotient rule. Well, from the notes, dy by dx is given by v times du by dx minus u times dv by dx, all divided by, didn't come out very well, v squared. So we need to identify what u and v are, find their derivatives, put everything into that into this formula here, and then tidy it up. Okay, so let u be 2x minus 3 cubed. That's the thing on the top. Now if we differentiate that, the u by dx will then be, we could introduce a substitution here and put in a few steps, but I'm going to do it the fast way, and that is by differentiating the bracket. So that means I get 3 times the bracket squared, and then multiplying the answer by the derivative of whatever's inside the bracket. So the bracket here is 2x minus 3, so when I differentiate inside the bracket, it's a 2. So if I put the contents of the brackets back, that's what we've got. So that's multiplying it out, 6 2x minus 3 squared. And v is e to the 3x plus 2. Again, we've got a function of a function, and just to make things a little bit easier, I'm going to put a little bracket around 3x plus 2. So what we'll find is the exponential of that bracket there. So when we differentiate it, we get, differentiate the exponential of the bracket will give us that. I'll fill the bracket in a moment, and then we differentiate, then we multiply by whatever the derivative of the thing inside the bracket is. So that will, derivative of 3x plus 2 is 3. So if I put 3x plus 2 in there, I've got my, all the bits that I need to go into my formula. So dy by dx is v, which is e to the 3x plus 2, times du by dx. So that means it's times 6 2x minus 3 squared, minus u, which is 2x minus 3 cubed, and dv by dx, well, it's that expression there. So I've got a 3, I'll just put the 3 in front of the bracket, makes it a little bit tidier, and an e to the 3x plus 2, so the bracket there, and that's all divided by e to the 3x plus 2 squared. Okay, and that is the answer. It's not a very tidy answer, so a little bit of extra work here just to tidy it up. If we have a look for common factors on the top line, both expressions have an e to the 3x plus 2 in them, and both expressions have a factor of 3 in them as well. There's a 3 there and there's a 6 there. So if I take 3 out as a common factor, and they've both got 2x minus 3 squared. There's a 2x minus 3 cubed here, so I can take 2x minus 3 out twice from that. So I'm going to get another common factor of 2x minus 3 squared. So I think that's all the common factors. Now if I take the common factor, this 3 e to the 3x plus 2 times 2x minus 3 squared out from the first term, I'm just left with a 2. And if I take it out from the second term, I'm left with a minus I've taken the exponential out, I've taken the 3 out, I've taken 2x minus 3 squared, so I'm left with a minus 2x minus 3. Now I'll put it in brackets because that minus sign operates on both those things. So I have to remember it's a minus 3 a little bit later on. And that's all divided by e to the 3x plus 2. Doesn't look very good, does it? Squared. Simplification. Well, I can cancel an e to the 3x plus 2 with one of the ones on the bottom, and I can simplify this bracket, and if I write it all out I get 3 2x minus 3 squared. This bracket here, 2 minus 2x minus 3 will give me 5 minus 2x, and on the bottom e to the 3x plus 2. As they say in the business, jobs are good. It's about as simple as you can get.